Hello, in this video let us solve a system of linear inequalities. So system of linear inequalities such as linear inequalities. So system means more than one. So here is an example. Let's say we wanted to solve x plus y is less than or equal to 2, and the second equation would be 3x minus y is greater than 3. So the way we solve a system of linear inequalities is the same way we solve each one separately. So what we do is we sketch the answer to each, and the place where the shadings intersect is our final solution. So the place where shading intersects is our final answer. And the reason it's our final answer is because that would be the place that is true for each inequality separately. And the place where they cross is the place that is true for both inequalities. And that's what we're looking for when we're solving a system. So let's sketch each one. So here is our grid, our coordinate axes. Let's move it. Here is x, here is y, here is y, here is x. Now let's sketch the first. So the way we do this is first we look at each inequality as if it is equal, it has equal sign. So how do we sketch something like this? One way is we can solve for the y. All we need to do is minus the x on the other side, minus x. And so in slope intersect form, that means we start at 2 units up, and then the slope is -1, which means -1 over 1. So the rise is -1, which means go down 1, and then 1 always to the right. So that's our two dots. And then we decide whether we connect them with a solid line or dotted line. If we have an equal sign like this in the original inequality, then we connect it with a solid line, something like this. Well, a little bit closer perhaps, like that. The next part is to decide which side of this line to shade, and all we need is a point that is not on this line, such as here where 0, 0 is, and if we plug in 0 for the x and 0 for the y into our original inequality, we will know which side to shade. So 0 for the x plus 0 for the y less than or equal to 2, which means 0 less than or equal to 2. Is that true or false? Yes, 0 is less than 2, which is true. So we shade all the side where the point is. The point is on this side of a line, so that's the side that we shade. And that's the part that is true for the first line. Then we do exactly the same procedure for the second line. So here's the second line, and we start off exactly the same. 3x minus y is equal to 3. How do we make a sketch like that? Well, we can solve for the y once again. That means we minus 3x from both sides, which is 3 minus 3x. And then to cancel the negative, we multiply both sides by -1, and that switches all the signs. So this line has y-intersect of -3. If we rewrite the equation in the slope intersect form, mx plus b, then we see that the b is -3, which means we cross the y-intercept line at -3. And then the slope is 3 over 1, so rise 3 units up, 1, 2, 3 up, 1 to the right is here. And then we decide whether we connect these two dots with a solid or dotted line, and since we don't have an equal sign, we connected with them with the dotted line or dashed line. So here is the connection for that. This line also did not happen to go through 0, 0, so once again I can reuse this point and test it to see if it's true or false. Now once I plug in 0 for the x, so here's my original equation, 3x minus y is greater than 3. I put in 0 for the x, I put in 0 for the y, which means 0 is bigger than 3. Is that true or false? Now that's false. And that means that this is not the side where the answers are. So looking at this line, this side is not the answer. It's the other side. This side is the answer. So we shade that side. Now the final result is the place where both our shadings intersected. We can see that this place is here, and this is the final answer. So on the test, we would have to remove all the other shadings. We would not be able to do it with a calculator, but if we use pencil and paper, then the final answer should not have any of the other shadings, because they are only true for part of the system, not the whole system. It's true for one of the inequalities, not both. So this is roughly what the sketch would look like. That would be the final answer for solving this inequality. So even though it's a bit strange to see a diagram as the final answer, that is exactly what it is. Now we could use the calculator to check the work and see if we shaded the region that looks reasonable. So here is the calculator. To use the calculator, we need to solve each equation for the y, and that is why we have done it here. So we will use this equation, and we will use this equation to make a sketch. But we will also use the inequalities. Now, one last thing is, when we solve the inequality, here let me re-solve the number 2 using the original inequality symbol. So the original was 3x minus y is greater than 3. And so if I repeat the same process with the inequality, we have to be aware of the sign. So here is what I mean. So what did we do? We canceled the 3x, so that makes 3 minus 3x. Then we multiplied everything through by -1. And each time we multiply or divide by a negative, we switch the original inequality sign to its opposite. So this becomes -3, the negative y becomes positive, the positive 3 becomes negative, -3x becomes plus. So the inequality is less than, y is less than -3 plus 3x. So this is what we will type in to our calculator, and with the first equation we simply move the x over, so we would have y is less than or equal to minus x, and that would be our first equation. So these are the two that we are typing in, and let's see what they look like. So here comes the first equation, inequality, y, 2 minus x. Now to make it into inequality, I have to move the cursor to the left and adjust the straight line here to the less than or equal sign. Less than sign is the triangle. That's a triangle going up, that's a greater, and that's less than. So that's the first inequality. Now the second inequality is the one down below. It also has the same symbol, so let's adjust that as well. It's a triangle looking down, and the equation is -3 plus 3x. And let's see what the solution looks like. That's our first shading. That's this one. This is our second shading. And the place where the shadings intersected, right here, that would be our final answer, and we can use the calculator to check it if we needed to. And that's it for this video. Thanks for your time. Take care.